Good morning, everyone. This is Jashwan. I'm from Sri Venkateswara College of Engineering. So, this video is regarding technical seminar on Loki, a physical security key, compatible IoT based lock for protecting physical assets. So, these are the contents for the presentation. So, now let's start with the introduction. There are many physical assets like currency, jewelry, or important documents. Some of them are most valuable things that we need to protect from being stolen or tampered. However, data is not the only asset we have. We also have many physical assets to be protected. There are various types of locks and vaults available in the market, like numeric, biometric, password protected, and so on. So the use of these sophisticated locks become more complicated and insecure for daily use. Moreover, the older generation is not so used to this technology to use modern day locks like PIN or password based ones. Implementing a cybersecurity features into the security of physical assets has been a challenge these days. Giving rights to vaults and lockers with PIN or password security, fingerprints, access cards for different personnel in a corporate structure, etc., is being in a trend these days. However, using the same set of physical security keys for securing both physical and digital assets can be instrumental in implementing access control for both seamlessly. So, moreover, keeping all data in motion encrypted using a symmetric encryption keys are instrumental in preventing man-in-the-middle attacks. Thus, this makes the lock secure against most known attacks. Also, there are many organizations like Google who have used FIDO2 security keys for securing their MFA. And also, there are many companies like Microsoft, several social media platforms like Facebook, Twitter, Instagram, Reddit, and many cryptocurrency wallets like Binance and Coinbase, and some of the online password managers like 1Password and many others. So now let's see some of the related background information. Most digital locks have leveraged PIN or password security or biometrics for safekeeping of physical assets. Mechanical locks mainly implement the use of keys for the same. These have become instrumental in protecting various physical assets like documents, currency, jewelry, etc. However, it is to be noted that such locks have numerous vulnerabilities. For example, password and pins once typed can be extracted by an attacker using suitable technology. Fingerprints authentication systems can be vulnerable to a wide range of attacks, including using an artificial clone of the fingerprint, printed images, or even extracting the fingerprint from the authorized user by social engineering. Mechanical locks and valves with physical keys are vulnerable to keys being stolen and can be used by the attackers. Also, it is known that the existing physical locks are vulnerable to many attacks. There are various types of locks which is more vulnerable than other, and it all depends on the different use cases. When it comes to Loki, Loki advances all the problems and offers a lock compatible with FIDO protocols, allowing the use of physical security keys. So the public key crypto system protects the authentication system, and the private keys never leave the security key. The protocols have been tested and proven successful in protecting digital assets. Moreover, the same physical security key can also be used for protecting digital assets in the corporate environment. Access control can be done quickly by provisioning and deprovisioning keys remotely by the administrator. So this is the comparison table comparing Loki with other physical keys. So there are many features listed where Loki is compared with many other physical keys like pin-based lock, biometric lock, and smart lock. You can check the comparison table by pausing the video. So now let's see working or implementation of Loki. In the first step, we have device registration. For registering our device, we need to scan the QR code with our smartphone. The registration process includes registering the username and email ID of the user. So once the username is entered, the cloud server will send an OTP. The email ID is verified with an OTP before saving into the database. Once the registration is complete, the registration of lock under the username credentials will be successful and the product will be ready for use. for the user. In the next step, we have logging in and key registration process. In the logging in, the user attempting to log in must enter their email, username and authenticate using an OTP sent to their email. Once the email is verified using the OTP, we can add the key. For key addition, the web page will prompt the user for the key to be connected to the USB port or scanned with NFC. Once the key is connected to the USB port, the cloud server will send a challenge to the browser to check the key details. When the verification of the key is completed, the key will be successfully registered under the entered username credentials. In the next step, we have authentication. As the user taps on the unlock button on the device, it prompts for the registered security key. It unlocks if the correct key is inserted into the device USB port. So once the key is inserted into the USB port, the system will check into the database whether the correct key is matching with the username credentials. Like already we have registered the key, it will match whether the correct key is inserted or not. Only then we can access the files. When the user wants to delete the keys, he or she logs into the dashboard with their username. The delete keys button clears all saved security keys of the device. You can also delete particular key or you can delete multiple keys. The reset device button on the dashboard is used to delete the keys and then remove the recording from the database. This will help in resetting the whole device to the new. Now let's have a look into our future work. This work can be further improved for smartphone-based remote unlock features. Other physical locks like car lock provide security with public key crypto systems and the symmetric crypto systems that may be proven to be beneficial. Loki has been validated with various security testing tools. It can be concluded that Loki can be used to provide physical security keys based on different cryptographic security to physical locks and many IoT based devices. However, it is to be noted that Loki also have some minor limitations that we need to overcome. Like one of the limitation is it requires to be plugged into power source to work. This might be overcome with the use of an external battery connected to the Loki. Another weakness includes it needs network connectivity to the server for functioning. If the server is hosted in an cloud across the internet, Loki would need internet connectivity for the usage. Otherwise, if it is hosted in an on-premises server, a wired or wireless connection like a LAN or WAN to the same is required for proper functioning of Loki. Now let's conclude our Loki presentation. Loki is a standard that allows FIDO to complement physical security keys. These are to be used with IoT based locks and can also be used for the safekeeping of tangible assets and many other physical assets. This enable users to manage keys with registered locks easily. In many different corporate scenarios, this standard can allow access control to physical assets. A reference implementation has been demonstrated with an SBC to show the concept. The performance analysis and demonstrated attack models using many real-time validations confirm that the proposed standard is at most secured in all the validated conditions and performs well. This presentation also discusses the advantages of Loki over the other locks, vaults, and lockers and exhibit how Loki is more secure. You can also check the comparison table of Loki with other physical locks in the previous part of the video. Finally, Loki has been implemented to develop a lock for the safe keeping of physical assets, and it can also be used for other forms of physical security like doors, door locks, and so on. According to the best of our knowledge, Loki is the first physical lock to implement FIDO2 based on security enabling seamless access control where users can be authorized or unauthorized from accessing the keys remotely. As the user has the whole administration of the keys, the user can authorize and unauthorize the keys whenever they want remotely. Take a look into our references, we have considered many papers that are published in different platforms like IEEE. to get the knowledge before starting off our Loki project. You can pause the video and check the papers or the references that we have considered for the successful completion of our project. As I said earlier, we have considered many reference papers. These are the reference paper continuation to the previous slide. You can check them by pausing the video. It's the end of our video. Thank you for watching. Please like the video, share the video, and subscribe to my YouTube channel. Thank you.